Okay, and the last section is 1.6, solving linear inequalities. Inequalities, we know, are things that are not equal, that we use to compare things that are greater than or less than. So in number 6, we have the inequality 3x minus 1 is greater than 6x plus 5. Now, first of all, we call these linear inequalities because they resemble a linear function without the inequality symbol. So if we were to replace that with an equal sign, we would get this to be of the form mx plus b, which is a linear function. So, but because it does not have an equal sign, it's not a linear function. It's a linear inequality. So we have to solve this for x. We treat linear inequalities just like a linear equation. That is, we get all the x's to one side, the numbers to the other side. However, you may remember that when you divide or multiply by a negative, you have to reverse the inequality symbol. So, in getting the x's to one side, I'll subtract 6x, and I'll add the 1 and get 6. So this gives me negative 3x is greater than 6. When I divide by the negative 3, I have to reverse the inequality symbol. So that is x is less than negative 2. To graph our solution, this is 0, this is negative 2. Put an open circle at negative 2 and shade to the left, because this would represent all numbers less than negative 2. And x is that. X represents all numbers less than negative 2. Using interval notation, our answer would be from negative infinity up to, but not including, negative 2. Now, if this symbol was a greater than or equal to symbol, then this would go from an open circle here to a closed circle, because we're including negative 2 now, and it would go from a parenthesis to a bracket to include the negative 2. So if we include the number, the equal sign, part of it has to be present underneath the inequality symbol, and that would get a bracket and a closed circle. If it's not there, then we just have an open circle and a bracket. So this is the interval notation. This is a graph of the solution, and that's our solution using x. Next, let's take a look at a fraction, number 14. Negative 5 over 6x is less than or equal to 3 over 4 plus 8/3 x. Because you're dealing with the fraction, it's most efficient to eliminate the fractions. So in order to eliminate the fractions, we want to multiply through by the least common denominator. So what's the smallest number that 6, 4, and 3 will divide into without a remainder? And that is 12. So I'm going to multiply everything through by 12. 12 divided by 6 is 2, times negative 5 is negative 2x. 12 divided by 4 is 3, times 3 is 9. 12 divided by 3 is 4, times this is 32x. So it just makes it a lot easier. You could deal with the fractions, but it's just a little easier if you eliminate them. Subtract 32x from both sides and get negative 34x is less than or equal to 9. Divide by negative 34 on both sides. Now, because I divided by a negative, I got to reverse it from less than or equal to greater than or equal to. And x would be greater than or equal to negative 9 over 34. Now, in graphing it, pretty small number. This is 0. This would be negative 9 over 34. Because we're including it now, we're going to get an closed circle. And all numbers greater than or equal to this will be shaded to the right. There's the graph. This is 0, or the origin. In interval notation, it would be a bracket at negative 9 over 3/4 to positive infinity. And of course we can never include infinity because we don't reach it. I did not reverse the symbol in the beginning because I multiplied through by a positive. I'm only reversing it in the end when I'm dividing by a negative or multiplying by a negative. The last three examples that I'll do are called compound inequalities because they contain more than one inequality symbol. So number 24 reads, negative 3 is less than or equal to 5x plus 1 less than or equal to 3. So what this really means, when you see this notation right here, if I have a is less than x less than b, it's very comparable to this. It's just not as lengthy as this. This means that a is less than x and x is less than b. Now to say that a is less than x means x is greater than a and x is less than b. So this notation here is an abbreviation for and. For example, if I have negative 1 is less than x less than 3, this would mean that negative 1 is less than x and x is less than 3. Or x is greater than negative 1 and x is less than 3. It means all numbers that are greater than negative 1 and less than 3. Okay, so that's what that notation means. It means and. How can you solve it most efficiently? Well, get the x by itself by subtracting 1 from both sides, or all sides. So then I get negative 4 is less than or equal to 5x less than or equal to 2. I'll divide by the 5 to get the x by itself, and get negative 5/4 is less than or equal to x less than or equal to 2 over 5. If this were a negative 5x, then I'd divide by the negative 5, reversing both of these symbols, by the way. How would I graph it? Negative 4 over 5 and 2 over 5, and 0 somewhere in the middle there. Because I'm including it, closed circle on both. And this represents, x represents the numbers in between negative 4 over 5 and 2 over 5. So that would be these numbers right here, in between. These are all those x's in between. It's the same thing as saying these are all the numbers that are greater than or equal to negative 4 over 5 and less than or equal to 2 over 5. It's these. It's the numbers they have in common. These are all the numbers greater than or equal to negative 4 over 5. These are all the numbers less than or equal to 2 over 5. These are the numbers in between that are both greater than or equal to negative 4 over 5 and less than or equal to 2 over 5. So the bottom line is you just subtract the 1 from all sides to get the x by itself, then divide. Using interval notation, it would be a bracket at negative 4 over 5 and a bracket at 2 over 5. That would be the answer using interval notation. Okay, next, number 28. We have the inequality 2/3 less than or equal to negative 4 over 5 times x minus 3 is less than 1. Okay, it's another and problem. It's a fraction. So to eliminate the fraction, I'll multiply by 15 because that's the least common denominator between 3 and 5. So 15 times 15 times 15. 15 divided by 3 is 5. Times 2 is 10. 15 divided by 5 is 3, times this is negative 12. Less than 15. Distribute. And I get negative 12x minus 36. To get the x by itself, I'll add 36 to everything. And I will get 46 is less than or equal to negative 12x less than 51. Okay? And then I will divide by negative 12. Now this time, when I divide by negative 12, I have to reverse my symbols. So it's going to be negative 46 over 12 is greater than or equal to x greater than just 51 over negative 12, or I can just put the negative up top. Okay. It does reduce down. 2 goes into here 23 times, and 2 goes into here 6. And what is this here? 4 goes into here 13 times, correct? 51, that's 52, I'm thinking. That's prime. So negative, it's divisible by 3, correct? What is 3? 17 then. So 17 times 3 is 51, yes. So we got that then. So that'd be negative 17 over 4. Yes, I was thinking 52. So, yes, 51 divided by 3 is 17, and 12 divided by 3 is 4. So that reduces to that. So then now, graphing this solution, we have here negative 23 over 6, which is equivalent to negative 3. 6 goes into 23 3 times, that's 18. 5's left over. 4 goes into 17 4 times, and 1's left over. So that'd be negative 4 and 1/4. So then in arranging this, we have negative 4 and 1/4, and negative 3 and 5/6. Because this one has the equal to, this one gets the closed circle, and this one's just an open circle because it's just the greater than symbol. And these would be the numbers that are greater than or equal to negative 4 and 1/4 and less than or equal to negative 3 and 5/6, right in between. And using interval notation, it would be a parenthesis at negative 4 and 1/4 and a bracket at the other end because of the equal to. You can also just keep it as an improper fraction. You don't need to convert it like I did. Okay, so not the nicest looking answers, but certainly we can handle that. Just to make sure, see here, when we divide it by the negative, we have to reverse the symbol on the inequalities. You know that from before, that 3 is less than, say, for example, 5. That is true. 3 is less than 5. But if I multiply each side by a negative 2, I get negative 6 is less than negative 10. Well, that's not true. So that's why I have to reverse it and make it negative 6 is greater than negative 10. Okay. So that's why I had to reverse this. And I just reduced it that 46 divided by 2 is 23, 12 divided by 2 is 6, 51 divided by 3 is 17, and 12 divided by 3 is 4. And 23 over 6, negative 23 over 6 is negative 3 and 5/6. Negative 17 over 4 is negative 4 and 1/4. And then I graph it open circle here because that corresponds to this one. Closed circle here because it corresponds to this one. And this is then in the interval notation. But one of these should be my bracket. It doesn't look too much like a bracket right there. Okay, and the last one is OR. Another way to join inequalities together. Number 36. X minus 9 is less than negative 1/2, or x minus 9 is greater than 1/2. So all you just do is solve each of them separately and graph your answer. So I'm going to add 9 to both sides. So x is less than negative 1/2 plus 9. So 9 minus 1/2 is 8.5, or you can get a common denominator. If you're bad with fractions, put the 9 over 1, multiply by 2 over 2 to get the denominators the same. So it'd be negative 1/2 plus 18 over 2, and 18 minus 1 is 17, so x is less than 17/2. Over here, when I add 9, I get 9.5. This is joined by OR, which is often used as this symbol. It's a U symbol. It means union. x less than 17 halves, x is less than 17 over 2, or x is greater than 9 and a half, or 9 and 1/2. So this is my answer right here, or I could use that symbol. In graphing it, the solution, this is 8.5, and this is 9.5. So x greater than 9.5, open circle here, shade to the right. X less than 8.5, open circle here, shade to the left. Now, how would I represent my answers using interval notation? Well, this corresponds to negative infinity up to 8.5 in union with 9.5 out to positive infinity. That's this portion right here. Notice I'm including parentheses because I cannot include these numbers because it's an open circle at each, and we just have no equal sign included. So these are all numbers from negative infinity up to 8.5, but not including it, in union with 9.5 out to positive infinity. We always use and ors in everyday life sometimes. In and, we're talking about the intersection between two sets, and with or, we're talking the union between two sets. Okay? It only needs to satisfy one of the conditions, but with and, we need to satisfy both conditions. Okay, so this is just how we solve two inequalities joined by or. Solve them each separately, graph your answers, and then unite your answers using or. And that concludes the last section.